Today's learning target is I can find squares of numbers and square roots of perfect squares. Yesterday we learned that if you have an exponent like this, that's called squared. 3 to the second power is 3 squared. And the reason it's called 3 squared, and I've tried to show you that right here. The reason for that is if we have a square means it's the same on each side, and obviously this square is not perfect. I drew it by hand, but I think you'll get the point here. So it has 3 units, 1, 2, 3 on this side, and 3 units, 1, 2, 3 on this side. Now if this was a perfect or a real square, it would be exactly the same on each side. You can tell mine's not, but you'll get the point with this. So if you remember from last year, you found area of squares or rectangles, and the area was the number of square units inside of something. So that's why we call this 3 squared. We're really finding the area of this square. Okay, and to find the area, you took the length times the width. Okay, it's a square, so it's 3 times 3. So we are saying that 3 times 3 is 9. There are 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 square units inside of this. So to find the square of 7, it would just be 7 times 7, just like yesterday, and that's 49. To find the square of a bigger number, let's say 23 squared, okay, I might have to solve this by actually writing it out. So 23 times 23, and when I work that one out, I get 529. Now that we know how to find squares, we can find what are called square roots. Squares and square roots are closely related. The difference is when we were finding squares, you already knew what the dimension of the square was. In square roots, we know how many squares are in the inside. So there's 16 squares here. So this, okay, what I'm drawing right here, this is called a radical sign. Radical sign just means it's the square root of 16 is how we would say this. So what we're looking to find is, we know it's a perfect square. So what are the two numbers that you would multiply by each other to get 16? But remember, they have to be the same because it's a square. So in this case, I know that 4 times 4 equals 16. So the square root of 16 would equal 4. Okay, so when I'm looking at this, if this were a square, it would have to be 4 on each side, and that would give me 16 squares in here. And so you can see how they're related. The 4 squared equals 16, and the square root of 16 equals 4. So when I look to find the square root of 81 in this problem here, I'm thinking to myself, what number times itself would give me 81? Okay, but remember, it has to be the same number. Okay, and I know that 9 times 9 equals 81, so the square root of 81 equals 9. So in this next one here, I have the square root of 64, and I think to myself, what number, when I times it by itself, equals 64? And I know that 8 times 8 equals 64, so the square root of 64 would be 8. Now let's say I have a problem like this, where it's the square root of a larger number, 169. So I'm thinking to myself, what times what would equal 169? Now in a problem like this, I'm going to use what I know. I know that 10 times 10 equals 100, and I know 20 times 20 equals 400. So I know my answer has to be between 10 and 20, because it's 169. And I know it's going to be closer to 10, because 169 is closer to 100 than it is to 400. So I also know that 12 times 12 is 144. Now that's getting pretty close to that 169 that I'm looking for. So what I would do is I would do 13 times 13.
And if I did that and I multiplied it out, I would get 169. So by using what I know, I could help me to figure out what the square root of 169 is. And so in this case, it would be 13.